Hello and welcome back. And in this video, we're going to be creating our own custom layout. So let's go ahead and get started. So I'm going to create a new file, and we're going to create this file basically as a CollectionView class. And we're going to create it from UI collection view flow layout. So that's going to be a subclass of flow layout, and we're going to call this snappy flow layout, like so. Okay, and let's go ahead and save this. Now we have this UI collection view flow layout, and most of the properties that are there, we can actually use them as is, but we're going to be overriding certain stuff. So go ahead and take a look by control clicking on UI collection view layout to see what all it provides, because there is a lot of information and really good documentation that's actually out there. So I would highly recommend you going through this, just understanding like how the flow layout actually itself works, and that will give you an idea for your own creative ways of extending these. But we can actually do a few things. So we're going to create our own properties. So first of all, we're going to create active distance. It's going to be of CG float type. And we're going to need this basically to normalize the distance when the view comes to the center. Basically, we're going to find out at which point we're going to have view snap to the center of the screen. So kind of like that. So that animation that actually happens, that determination is going to be like, at what distance view should snap back to the center, or it should basically go back hiding. So let's say, like, if I come halfway through, then it should take this view, and if I come not so much halfway through, then this view should remain, and the other cell that was scrolling should go back to its own place. So that's what active distance is going to be used for. We also going to need zoom factor. So we're gonna create that one as CG float as well, and we're gonna put 0.3 value for that. So I would actually say, like, I've tested these values with this layout that I'm creating. So play around with it, like, make changes, see how it affects your layout and everything, and it's gonna actually be more learning for you as you actually change this, how the behavior changes along with these values when you change them. Okay, we're going to override init. So we're going to first call super.init, and we're going to call a view called function called setup. So we can have a private func setup, and we're going to call that inside our init. Okay, we're also going to need required init. So we're going to just call super.init a decoder, and then call setup over here as well. Okay, now in the setup, we're going to set two things. We're going to set scroll direction. We know our views, our cells, or our collection views, scroll direction is always going to be horizontal. So we're going to just say horizontal. Minimum line spacing, we know is going to be static, so it's going to be 40. So the line spacing between the views, between the cells, is going to be basically 40 points. And then I'm going to create another function, get collection view, and this is just a convenient method to basically get the collection view from the view layout. So when the view is when this layout is initialized, you're gonna have collection view, and for certain operations we're gonna need this collection view, reference to this collection view. So instead of, like, guard letting every single time when we need it, I'm just going to create this convenient function that's gonna actually, when it's called, it's gonna unwrap collection view from guardlet, and if collection view is not there, it's gonna throw an error, but if collection view is there, it's going to return that collection view. So simply guard let collection view is equal to collection view, else fatal error with message collection view is not present. Okay, and otherwise we can simply return our collection view unwrapped. Right. Okay. Next thing we're gonna create or override prepare. Now this method is called at the beginning of code layout process, and this is the opportunity basically for you to perform any kind of pre-processing. This method will determine the size and the position for every cell, supplementary view, and decoration views. Computing the size of the cell's scrollable content area basically this is where you're gonna do it. Initializing layout attributes and storing them, this is where you're gonna do it. And basically this method is where you decide what the layout should be, or what the layout is gonna be for your custom layout. Okay, so that's what the prepare method is for. And in our case, we are gonna first create a collection view, and we're gonna call the get collection view to get the collection view reference. We're gonna create a variable width from collection view dot frame dot width times 0.6 to basically get 60% of the width. And similarly, we're gonna get the height. That's also gonna be 60% of the height. Then we're gonna basically define our item size. So CG size. Alright, next we're gonna create our vertical inset. So basically the vertical inset for a cell. So we're gonna simply say vertical insets, and this is gonna be collection view dot frame dot height, and we're gonna subtract collection view dot adjusted content inset dot top minus collection view dot adjusted content inset dot bottom. So we're gonna have the inset, but if there's any content inset that's defined for the cell, we're gonna actually subtract those two from the collection view's height first, and then we're gonna subtract the height that we have computed, that's 60%, and we're gonna divide this by 2. Okay, so this is going to be our vertical inset. Then we're going to have horizontal insets, and this one is going to be pretty similar. So collection view dot frame dot width this time, and we're going to do left and right. So collection view dot adjusted content inset dot right minus collection view dot adjusted content inset dot left minus width, and we're gonna divide this by 2. Okay, so we're gonna have like 2 insets basically for left and right for the horizontal space, and then we're gonna say section inset is going to be UI edge insets, and we're gonna give top to be vertical insets, left to be horizontal insets. The bottom is going to be once again vertical, and right is going to be horizontal. And let me singularize this name because it's just one inset. So instead of calling insets, it's just the inset. Okay. All right. Cool. Now we are simply gonna call super.prepare. So whatever remaining setup that collection view that collection view flow layout needs to be doing, we will allow that to happen in the super class. So that's why we're going to call super.prepare after we have done our settings. Okay, so rest of the stuff is going to take place in the super view. Now what we need to do is basically we need to define layout attributes for element. So we need to override layout attributes for element, and this is where you're going to basically create that zoom effect for your cells. So first let's get the collection view. So collection view, get collection view, and then we're gonna first get rect attributes. So super dot layout attributes for elements in rect, and we're gonna map this. So we're gonna unwrap this and map this, and we're gonna say a trailing closure we're gonna use for the map, $0, so first element dot copy, and we're simply going to use empty overload for the copy as UI collection view view layout attributes. So we're going to get all the attributes for the current rectangle that's in place. Okay, so you're going to get all the layout attributes for that element, for whatever elements the rectangle the present rectangle is in. Okay, then we're going to say visible rect is equal to cg rect, so the portion of the collection view that's visible, and we're going to say origin and the size. So we're going to take this one, and we're going to say collection view dot content offset, and the size is going to be collection view dot frame dot size. Okay, so content offset is going to be what we're going to use as the origin, and the frame collection view's frame size is going to be the size of that visible rect that we're going to be showing. Okay, once we have completed these two, we're going to say for attributes in rect ATTRs, so rectangle attributes, we're going to say ATTRs dot frame dot intersect. So if it intersects to second rectangle, so basically if the attributes that we have, its frame intersects with the visible rectangle, okay, if that happens, there is a closure block, and what we're going to do is we're going to say if it frame dot intersects, so actually this is slightly different. So we're going to say where, so we're going to say for all the attributes, get all the attributes where attributes dot frame intersects with visible rect. Okay, now when that happens, what we need to do is we need to compute distance, and we're going to say visible rect dot mid x minus ATTRS dot center attributes dot center dot x. Okay, so we need to get the distance between the visible rects mid x and attributes, the attributes currently selected attributes center dot x location, or x coordinate. Then we're going to normalize distance by dividing distance with active distance that we have defined at the top. Okay, so let me do Control I to format the code, and there's an extra, I think there's an extra parenthesis, so let me remove that. Okay, alright, so if distance dot magnitude. So we're going to get the magnitude for the distance is less than active distance. So active distance is basically 200. Um, and if that is the case, then we're going to say zoom is equal to 1 plus zoom factor times 1 minus normalized distance dot magnitude. And then we're going to take attributes and apply 3D transform. So CA transfer 3D make scale, and we're going to say make scale to zoom. Okay. So 3D transform, this takes three values, x, y, and z. Z is going to be 1, and x and y properties are going to be basically computed based on the zoom factor and the normalized distance magnitude. So we're going to compute that, and then we're going to provide z index, and that z index is going to be int value of zoom dot rounded. So rounded zoom value is what's going to be the z index value. So, and we're going to return this rect attributes as a part of this layout attributes for element function return parameter. Okay. Now that's actually our cell zooming is done. The zoom effect that we are actually giving here. Now we're going to override target content offset. So when transitioning between layouts, the collection view can call this method to basically give you the opportunity to change proposed content offset and use this basically at the end of the animation. So basically it actually gives you an opportunity to compute the offset that you can have, and you basically override this method to give cell like snapping behavior. So like when the transitioning is happening, that snapping behavior suddenly happens, that this kind of like that. If you notice in the animation, there's a zoom in, zoom out, but cells are snapping in place. That behavior is given using this target content offset that we're going to be creating next. So we're going to be overriding. So target content offset, and we're going to use the one that takes with scaling velocity, with scrolling velocity, and we're going to first get our collection view. Okay, and then we're going to create snapping behavior. So let target rect is equal to CG rect. Frame dot width, frame dot height. Okay, so basically we're going to create a new rectangle with proposed content offset. The new content offset that's actually being moved, that's being provided for the cell that's being moved. So we're going to take x value of that. Y is 0 because we are doing only horizontal scrolling, and then width is going to be the collection views width, and the height is going to be collection views height. Okay, then we're going to say guard let rect attributes, layout attributes for element in target rect. So we're going to get attributes for the target rect. If there is nothing, then we're going to simply say there's a 0 snapping. So if there is no rectangle being intersected at that point, in that case, like, we're just going to return 0. Then we're going to have var offset adjustment. So we're going to adjust the offset. greatest minus magnitude is going to be the value that we're going to use, and we're going to say horizontal center is equal to proposed content offset dot x plus collection view dot frame dot width divide by 2, and then we're going to say for layout attributes, okay, for layout, for some reason I'm not getting the autocomplete, so let's see, missing return type. So let's put a return type, but I want to actually calculate. So for layout attributes in rect attributes. Oh, yeah, that's the variable name. Let item horizontal center is equal to layout attributes dot center dot x if item horizontal center minus horizontal center dot magnitude is less than offset adjustment dot magnitude, and these values are pre-computed after playing around with so many different options. That's why I'm just typing those because based on your need, actually you can adjust these values and see, experiment with these, see how this changing these horizontal center with computed horizontal center magnitude and offset adjustment, basically their magnitude. If you change these values, how it affects your collection views layout. Okay, but we simply gonna what we're gonna do is we're gonna return CG point, and that CG point is basically content offset. That's what we are actually providing, and we're providing x and y values. So proposed content offset dot x and proposed content offset value dot y. But for the x value, we're gonna also add offset adjustment that we just computed. Okay, so we're gonna actually provide that too. Now we also gonna override this should invalidate layout. That takes basically simply returning true, and this actually just invalidates the layout for every single cell when zoomed. So basically we can provide that zoomed effect. So it's going to invalidate the layout for that cell, and the zoom effect is going to basically taking place. That's why we are actually going to say should invalidate should invalidate layout for every cell. So it's just going to return true. Now there's one last function that we need to override. It's called invalidation context. Invalidation context, and we're going to use for bounding change 1. And basically what this does is creates the invalidation context object that is responsible for using context object to update layout efficiently. Now, this creates the invalidation context in response to specific changes, like when you rotate your phone, or when the layout changes, or when the data source changes. For example, when you insert or delete items into the data source, and when you call a reload method, that's when this invalidation context object is basically changed and it's created. So it actually reflects the invalidation context for you to use into for the new layout. So should invalidate layout actually then triggers in and makes some more room for newer content to be available. So when you're on the last cell and you inserted a new cell, that new object is going to be basically available by calling this invalidate context object that was created for you. Okay, so we're going to simply what we're going to do is we're going to say collection view, get collection view, and context is going to be super dot invalidation context for bound, and we're going to supply new bounds. here, and we're gonna cast this as UI collection view layout flow layout invalidation context, and we're gonna say simply context dot invalidate flow layout delegate matrix is equal to new bounds dot size, and we can simply compare that is not equal to CollectionView dot bounds dot size. Okay, and we're gonna return this context. With that, our snappy flow layout is actually ready to be used. So what we're going to do is we're going to go back into our view controller. In the next video, we're going to simply build out this piece where we're going to add it to the collection view and add the collection view to the view controller and show it. Okay, so let's hop on to the next video, and we're going to basically make some adjustments to show the collection view inside the view controller. Okay, I'll see you guys in the next video.